Okay. Nazira?
Включила.
Dear participants of today's event, today we will discuss the implementation of blockchain projects in Estonia, and our speaker is Ivo Lohmus. He is from an Estonian company called Guardtime. This company is a participant of different projects in Estonia and took participation in organization of different projects. So we will discuss. Dear Ivo, we are listening to you.
Okay, thank you. I will try to share my screen again.
Okay, we see it.
Do you see? Okay.
Yes, we do.
Very well. So first, hello. I am Ivo Lõhmus from Guardtime, and I work as a program manager for public sector. So I'm mostly doing integration projects and case studies with Estonian government institutions. And I will try to give you a quick overview about blockchain-based security and how we can use it to secure and audit public services. But first, a few words about the company. We are a systems engineering company, mostly operating in the fields of applied cryptography. And we were founded here in Estonia around 10 years ago. But today we have quite global reach. We have around 130 employees.
I see.
Around 50 are in Estonia. So our research centers, security engineers, cryptographers, developers are mostly in Estonia. And our second biggest office is actually in Irvine, California. So we are quite globally distributed.
I see.
And we have some quite big or important customers, mostly from the sectors of defense and telcos. So for example, we have Ericsson as a partner. Our customers are Lockheed Martin and Raytheon in the US. And also some governments. And our biggest, as we have Estonian roots, our best cooperation has been with Estonian government. And the problem we solve is the problem in cyberspace. It's a lack of integrity. And integrity is much more than just checking whether your document or database record is good. It is verifying a lack of compromise, and this is relevant everywhere. And this problem is actually quite hard to solve, and we solve it by blockchain technology. But first, let's briefly review the background or why it is so hard to solve. So typical approach is to secure systems by building a fence around them and then guarding the fence. But this just doesn't work all the way. You have no means to be sure that the fence is intact, and you rely on trusting people inside you. You have definitely heard of Edward Snowden, and well, I am not judging whether this was good or bad, but it's a fact that an insider could work in an organization for more than a year and cover up the tracks, and this is something you do not want to see in an organization, especially when it's sensitive government data. So we take a different approach. Instead of building a fence, we guard the data itself, and we have developed technology called keyless signature infrastructure, which is essentially data signature that proves you three things: integrity of the document, signing time, and signing entity. And then you get to assert these things upon every verification. So the concept is that you get security by situational awareness. So we cannot stop an attacker, but we can give instant alert and immutable proof when there is a breach. So this may sound simple, and the concept actually is, but traditional tools are just not plausible to achieve this at needed scale. For example, let's say it's technically overcomplicated and definitely economically unviable to digitally sign all assets with a PKI signature, because it just doesn't scale. But the scale we are talking about, as a keyless signature infrastructure, we're talking about billions of items a second. So it's a blockchain technology for verifying integrity of systems at the internet scale. And as I already mentioned, the scale is massive. So today the network is capable to support actually 10 in the power of 12. So that's trillion keyless signatures per second. And maybe even more important is that it is independently verifiable. So you take a signature from us, it's purely mathematics. You can verify it and use it as forensic proof in court if needed, totally on your own, without trusting any third parties or any insiders, or even including us. So it's totally independent, well, as a blockchain should be. And the concept is that customers send us hash of their data, and we give them back a signature. So we never ingest any real data or any transaction, something like that. So there are no privacy issues. And of course, maybe today it's not a concern yet, but in the event of practical quantum computers, as we know today, the PKI infrastructure is very vulnerable, and hash cryptography is not. So we consider the technology quantum immune. So let's briefly review how this technically works. Do you hear me well?
Yes, we hear you.
Very good. So basically, it works like this: that a user computes a hash of an asset and sends to us, and this can be any asset. You can basically apply hash to anything. It can be your firmware, it can be your whole database, it can be a single log line, and we gather these requests together, and then we apply the concept of Merkle trees, or binary hash trees. So we take hashes, we pair them together, one level up we aggregate on, and so when we use this layered aggregation, essentially we build this triangle that we end up with a global root hash value, and all the members or all the requests who participated can compute to prove that they can reach this global root hash value, or this way to the top. And then we store this global root hash value to the blockchain, and then we throw away the rest of the tree. So essentially, and this is what we do exactly once a second. So globally, we gather together all the requests. We give every requester back their hash chain or their way to the top. We store the root to our blockchain, and then we start again the next second. There are many good properties with this. For example, for us there is no exponential growth, or there is, let's say, no load depending on how many signatures to issue. That in the top we compute one value and store to the blockchain, regardless whether in that second there were a million requests or it was just one. So we just had one value per second, and there is no this explosive growth. Now to the blockchain, how this works. So it is a permissioned blockchain. So we control all the nodes in this distributed database. So as we trust the nodes who put this together, there is no proof of work. So we can determine within the second that the value is value computes and good, and we can commit it. And then we near real time distribute this database to basically all the requesters' access gateways. So it can be publicly validated. But still, it's bits and bytes managed by a private company. So obviously you need some stronger trust anchor than our word that we are doing a good job. So what we do, we basically build a similar hash tree on top of this blockchain database as well. So actually this is ever growing, and the tree would lean towards the right on the image. But we hash together all the values in the database, and this means that effectively each second global root hash value is tied to all the previous ones. So you cannot take anything in between, or you cannot change anything, then it just wouldn't compute. And to get even, let's say, more widely witnessed event or stronger trust anchor, we regularly publish this top of the database hash value in a newspaper. Today we use Financial Times Global Edition. So this gets like 250,000 copies printed. So if you want to fake or backdate the keyless signatures that we have issued, then you need to collect majority of the newspapers from all the libraries and archives, and as they are all linked together, all the following ones as well. So this is considered an impossible thing to do. So, and this gives you this independent forensic proof. So let's say you have a signature on your data, and you need to prove in court that it is valid. And well, it's probably quite feasible today, but let's say you need to do it from an archive, I don't know, 30 years from now. Maybe we are not offering that service at that time, this online service. So all you need to do, you take your original data to recompute the hash. You take the signature you received from us, and then you go and bring, or let's say court expert bring a copy of a newspaper from library archive, and then compute it out or validate it fully offline and on your own, even in the event that maybe we are not offering it. And this concept of getting integrity, as I mentioned, is that you sign a data, and the technology is really scalable, so you can take thousands of millions of signatures a second, and as validating the signature is just recomputing the hash chains. So there are no private keys, no secrets to guard, no certificates to check, so you can check them offline. So you can effectively sign all your firewall rules, configuration files, log lines, database entries, and so on, and regularly check and validate does it still compute. If it doesn't, you raise a red flag and check. And this means that when someone tries to do something unauthorized, and then tries to, let's say, delete the log file, then you will immediately notice. And this is a concept that we have applied in the public sector, also in several Estonian institutions. So first, the Center of Registers and Information Systems. This is shortly the IT department of the Ministry of Justice, and they run several critical public registries and services, and quite a few are secured by KSI blockchain already, or are about to be launched. So of course the key motivation is to ensure integrity, that attacks and insider jobs cannot be covered up or go unnoticed. But there is more. So such services like business registry, property registry, Riigi Teataja is our this sort of state gazette or something that all the laws have to be announced there to come into effect. So they need to be auditable. And KSI allows these government institutions, these registry owners, to transparently prove that they are doing a good job. And on some cases, this proof is needed on a daily basis. So one of our recent projects is a digital court files. So all the documents produced in the courts of Estonia, we are moving to a completely digital governance, meaning there will not be papers at all or no paper original to refer back to in case of disputes. And of course, in court, all the documents and everything needs to be accountable and legally valid. So all the court files produced get signed by KSI and hash chained together, and then they are, with a scheduled job, regularly verified. Are they still good and untampered? Okay. Can I move on?
Okay.
So one of the recent or most recent projects that is still currently ongoing in Estonia is our integration to the Ehealth Foundation. Ehealth Foundation is an institution facilitating communication between hospitals and medical centers. So all the patient records, prescriptions, X-ray files, and so on, they get pushed from the hospitals to this database of the Ehealth Foundation. And let's say I want to go to different hospitals and my file is already there, or actually there is online service so that citizen can log into the state portal and check their medical record and which doctor has viewed their data and so on. And obviously, to run such a service with very sensitive data, the provider needs to meet quite strict regulatory compliance rules. And KSI helps a lot here to ensure integrity, so that we can trust the database managers, but independently. So we just don't need to trust that they say that nothing has happened, but they can also prove it. So we have all the records get signed, and more the database audit log, so all the transactions and access logs get signed. So this means that we have proved that we can prove that, let's say, access logs produced to this medical records database are valid, haven't been tampered with. It's not possible for someone to go change something and then change the log as well and totally hide it. And one important thing about this that such sensitive data needs to be accessed and proven in isolation. Shortly, what it means. If you can imagine, there are millions and millions of records, and actually hundreds of thousands of updates are done every day. So it's not really reasonable to go and take a separate signature for each record, or every time make a network request, which takes more or less like 1 second. So we have to sign them in bulk. So, but let's say you take a log file of maybe 1 million entries and sign it and store the signature. It's very trivial, works very well. But the problem is that when you need to prove, then in order to prove that it's valid, you would have to present the whole log file or the whole database table. And this is not viable, because even by law, I'm not allowed to show the neighboring records of some other persons. So we have built a technology that you can effectively sign it in bulk, but it's cryptographically linked together line by line. So when needed, I can present a proof of a single record in question without revealing any neighboring data. And moving on, our cooperation with the Estonian government is actually nowadays through the Information System Authority. This is the authority in Estonia who sets policies for other ministries and organizations on the state level. For example, they are managing our this data exchange layer X road, maybe you have heard of, and they are managing technically the Estonian ID cards, our PKI infrastructure, which means we can do everything online basically. So we have given a couple of service success gateways and also needed software and setup to the state authority, who is running it and who is facilitating or sharing it to all other government users. So this is just, let's say, efficient for us. So we don't need to talk to all the government institutions ourselves. But secondly, this really simplifies this joining or onboarding process, because a state is offering it as a service, has a contract with us, and for all the other state uses or organizations, they can basically join without telling us. They don't need to sign a contract and so on. So it's really simplified. And well, I don't have the introduction slides here about our Estonian X road, but essentially all the government databases and services are distributed in Estonia, and they interconnect with a central layer called X road. So we have developed an X road adapter. So all the government institutions in Estonia are integrated to the X road, so they can use the service to secure their application without the need of doing a new integration. So we are in a state that everybody or all the government institutions in Estonia can just basically start using the blockchain for security without anything else, and just figuring out how to integrate this to their application. It is really a new thing, just started a couple of months ago. So we hope that this brings us many new use cases. And of course, the Information System Authority itself is also using the technology mostly for securing audit and access logs, so that they are tamper-proof, and if there is some incident, then they can be sure that the produced logs haven't been tampered with. And I just added one interesting slide here, or it's a project ongoing in Estonia. I was at a conference yesterday in Finland, and I didn't realize it before, but then I learned that Estonia is the first country in the world who has legacy issues with digital signatures. We have had legally valid digital signatures for more than 10 years already, and the first ones they were based on SHA-1 encryption, which is not considered that safe today anymore. So in order to ensure that these contracts digitally signed using the old encryption method, and there are millions of them, because, well, digital signatures are really popular here in Estonia. So to store them in an archive so that they would be valid even tens of years from now, there is a project that the Information State Authority will give people a utility that will search for your old digital signatures in your computer, sign them over with our keyless signature, and then store in this today's format. So this means that even when maybe 20 years from now the old SHA-1 will be broken, then the signatures issued today will still be secure and safe. And well, this is mostly intended for technical people. That if you have more interest to understand how it works, to try it out, then we have a developer program. So we give you for free a fully functional service access. It's not limited in any way, and you will get this. You will get to join it. You will get really comprehensive documentation, and can try it out with, for example, with some command line utilities without even needing needing to be a developer. So architects, people who are reviewing or evaluating the technology or how it fits, are really welcome to just fill in your email at the link, and we will shortly send all the access details. And this is it for my presentation. I would be happy to answer any questions.
Okay, thank you very much, Ivo. And dear participants, have anybody any questions? So
I've got a question, Timur.
Okay.
Okay.
Yeah.
Thank you for interesting presentation. I've got the first very simple question. Why is Ehealth, and why your technology starts from such area of public administration and e-governance? Why is Ehealth? Why not is something like finance that is very popular in the world?
First, we are not really in the area of financial services. Yes, we could, but first, everybody's trying to do that with a blockchain, and the technology we have is really like, I don't know, electricity 100 years ago. That you need to build applications for it. So we are currently mostly focused on the areas of defense, telcos, and public sector. And in public sector, we don't try to solve the financial problems. We try to solve the integrity problem. And medical records and proving that they haven't been tampered with is considered a critical thing. Let's say this all regulations and policies and everything regarding the finance area are already today more stronger. So yes, it is logical to go there as well someday, but we have started with other things.
Okay, thank you. And another one question. As I know, the Baltic country has already tested a blockchain-based identity platform for digital authentication of Estonian.
Hello? Sorry?
Ilya? We don't hear him. I think it's some problem. In a few minutes we will hear to him.
Okay.
In a few seconds. Ilya? So just a second.
Okay.
And dear Ivo, I wanted to ask also how popular services on blockchain in Estonia. For example, I mean, how many people use the opportunities of Ehealth program, and is there any services on paper still in health sector?
Not that much. For example, when I go to the doctor never writes anything with a pen. For several years already. So everything is electronic.
At present time, only on blockchain technology.
No, I mean, as we are just adding the blockchain there as a security layer, and this is still ongoing. It is not in production yet. But for example, the registries like business registry and property registry and court files and so on, this is already in production. But as you understood, this technology is different to the Bitcoin blockchain, where it is the data gets loaded to the ledger, but it has many problems, like it's very slow and cannot handle the load. So the concept with the government services that we take here is that still the government runs it and government owns the database, but it is secured by blockchain so that it is sort of auditable, it is transparent, that they cannot secretly change anything, and so the people will know. So and for that we have used it for some registries and things, but it is still, of course, ongoing, and I think we have something like 1,500 digital services in Estonia. So obviously there is a lot more work to do.
Very developed. Okay. Ilya, do you hear us? Maybe someone else wants to ask from our speaker different questions. So I think in a few seconds he will join us.
Okay.
And your company, Grab Time, has your company realized other projects in this sphere in blockchain? I mean, in introduction of blockchain technology in public service.
In public service, well, we have some ongoing projects. We are, it's also being evaluated, and in some places there are pilots in the American government. Then we are it's used to secure a nuclear plant data in the UK. But well, I'm mostly working with Estonian government projects, so I don't know all the details, unfortunately. We are not really a small startup anymore, so I have some colleagues who I don't even know.
And about e-notary project, I wanted to ask also.
The e-notary, yeah, okay.
Impact of this project on the business activity and investments. Do you know how many business units came to Estonia after realization of this project? E-notary, as I know.
You mean e-residence or e-notary?
Yeah, sorry, e-residence.
Yeah.
E-residence.
I'm not really sure. I mean, I'm not really involved, or a company is not involved there. I think I've seen figures that we have today something between 10 and 20,000 e-residents, and they've started like a couple of hundred companies, something like that. So more or less the area. I don't know all the facts.
I see. Ilya? Okay. Just a minute.
Okay, and I can also basically I can send you this presentation, so you can review it. If you have possibly more questions, then we can have a follow-up session, or you can write me by email, and
okay, thank you very much.
Also just in advance.
Okay, thank you very much. It will be interesting for us. So, Ilya, maybe other participants have questions to our speaker? Oh, Ilya joined us. Ilya, please. Ilya, maybe you will write your question. Just a moment.
Okay.
I think
yes,
sorry?
maybe I can have a question.
Okay.
Can you just very shortly with a couple of words say what is your objective, or what are you investigating or trying to understand?
You know, by the end of May, we are planning to hold the Astana Economic Forum, and in this forum we will have one session which will be dedicated to blockchain technology. And at present time, we see that different countries all the world, they use this technology, and different officials say that this technology brings big opportunities to public sector, and we are also interested in opportunities of this technology, and we want to investigate it and to research opportunities for our public services and for our public sector. And in the forum, at the forum, we will discuss also these opportunities. Before the forum, we also discuss these opportunities on the conferences, and I think after all of these events, we will shape and we will formulate our policy about this technology, and after it, we will maybe make some decisions on the development of this technology and the implementation of this technology in our country. And I hope that in the future we will all of this information will be useful for us, and then we will work in this direction.
Okay, and are you working for the Kazakhstan government, or are you a research organization?
We are working for Kazakhstan's government.
Okay.
For example, I'm working for Ministry of National Economy, and other participants they work in our Kazakh Telecom company, which is which also shapes the policy and takes participation in the realization of policy of information development of Kazakhstan.
Okay.
So we are.
Okay, sounds interesting, and yes.
Just a moment, Ivo. Just a moment. Just a moment, Ivo. I will call to Ilya.
Okay.
And he has some problems with the connection, and I will ask something about. He had some questions. Just a moment.
Mm-hmm.
So, dear you, Ilya had the question, and I wrote it. You
Okay.
see it at the monitor, and you have answered it.
Yeah, I'm trying to.
Another participants, do you have any questions to our speaker? they ask about presentation, and you are answering that you will send
I
it.
will
Don't
send
know.
it.
So I think they don't have any questions at present time, and I think for this time maybe we will finish our conference, and then if anybody have questions, we will contact you.
Please.
We have your email, and I also want to thank you for your this report, for your readiness to take participation in this event, for your readiness to share with us your presentation, and also I wish you good luck in your work, and hope you in the future we will also we will be partners with you, and
Yes.
our work will continue. So thank you very much, Ivo.
Thank you. It was my pleasure. So I will shortly send you the email with details, and then please distribute it as needed.
Thank you very much. Bye.
Thank you. Goodbye.
Bye. Bye.